Hello my friends, how are you? Okay, so far we know almost everything about the well. I have brought about the same well from previous videos so that we can remember what we're talking about. So far we know the maximum potential that the reservoir can put in the well. We know the lifting system. We know how much we're going to produce. And now we have to take those volumes of fluids, gas, liquid, take them to the gathering systems. Could be a flow station, could be a manifold, could be, whatever we have, whatever is the case. Okay, so we are ready to take all we produce to the gathering system. We need to be aware of the surface equipment of this system we installed, okay? Because most of them can be automated with VSD, so we need to know that. Right? Remember the energy we get from the lifting system, from the bottom hole pressure. It should take all the fluids to the next point. If we are in the case that we cannot do that, we need to use boosters, okay? So we have the desired fluids at the wellhead. We have the bottom hole pressure, which is the blue line. Remember that? We have the bottom hole pressure. I'm sorry, but this blue line should have been from here. So we know that we also know the THP that we expect. And we do that. How do we do this in the software? We put a nodal node in surface, and we disactivate the one in the bottom and activate this and run the software again, and we get what head pressure we should be getting when the well is producing that rate. So then we connect the well to the nearest point. Where is my fluid going to? I need to know that. If we have many wells in the gathering system, we start to simulate with today's manifold pressure. That's the pressure we're going to start. By the way, we're going to see it in a minute. Whatever gets out of the reservoir and lifted by the artificial lifting system is the volume that we are getting, because I'm going to tell you in a minute what some engineers thought in one of the companies that I worked. They thought in the manifold the wells start killing each other and the well is not producing the rate. Whatever gets out of the reservoir according to the nodal analysis, that's what we are getting in surface, okay? Nobody's going to kill that well, right? We're going to see that in a minute. So the first, I'm going to put here some example of gathering networks. When we are in front of a remote well, like exploratory well, we have to use what we call early production facilities. And that's what they call the well testing. Depends on the fluid we're expecting. If we're expecting heavy oil, we should include some steam, steam facilities, heat exchangers, things like that, according to the fluid we're expecting. That we use separators to get the gas. We use tanks. We can use gun barrels. So we include everything. And finally the tanks, the stock tanks. So we get what we get, and we put it in the trucks, and it goes to the next gathering system. The gas normally is burned here, okay? So that's the first that's the first flow, gathering facility we have. It's the same as the permanent. Normally, it's the same as the permanent. In fact, we did a study for a field that it was going to produce around 2,000 barrels per day. That was the expectation. So we told them, you can use the well testing facility, and you can keep them. You buy them from the supplier, because it was not going to grow very, very big. So if this is the case, this is the case where I worked. And this has a lot of wells, and you know, that's a lot. I mean, that's a case that we manage in a country in Latin America. So that you can see, and the Lake of Maracaibo is also like this, very big. And this is a this is a design for a cluster. You know, where we put 5 wells. We have a testing manifold right here. We can go across a Coriolis if it's the system that can work, and then we have the general manifold. So if we test the well and the well has 100 pounds in THP, and when we put it with the rest of the wells, it keeps the 100 pounds. The well is producing the same when it's being tested and when it's with the other guys. Okay, have that in mind, because some people confuse that. I'm talking about the company where I was. They said they started killing each other right here, and I told them the THP is the same, but they say no, that doesn't have anything to do. Of course, if we keep the same THP in the well, nobody's going to kill nobody. Okay, okay. In offshore, depending on the case, this is about what we had in Maracaibo. Of course, 1,000 of those, but it was like this: a flow station where the wells, these are the verticals of each one of the wells. Each one has a flow line. So each one of the wells was gathered, all of the wells were gathered here, and we got to separate the gas. The gas, after the scrubber, the gas was going to the compressor, and the liquid right here in the tank is pumped with no gas. Oil and water they were pumped for, by each one of the flow station, and a booster, because they didn't have enough pressure to get to land onshore where the tank farm was. So we had a booster in between, so they can be repump and get here. So that's another configuration depending on what we have. So, okay, and depending on what we have, we design the facilities, right? So what happened in the software when we do this? We have the well, we have the potential right here, the 9,000 barrels. The energy in the ESP is enough to put the fluids in the manifold. Once it is in the manifold, it gets together with the rest of the wells and is pumped, pumped to the CPF, whatever you have. Okay, depends on you have, and depending on what you have, you design and you see the pressure drops across the whole system, and you make sure you get what you have to get with the fluids with good pressure as low as possible, because depends on what you want. You decide. Everything is economical, because if we have a well like this, or if we have 1,000 wells like we saw in previous slide, and if we are including too many wells and the pressure is going too high, we can lower the bottom half ratio of the well with more hertz, more electricity, but that's a lot. That's very expensive. So what we did in a field like this, the one that I showed you, the huge one, was we prefer to construct another trunk line to reduce the pressure and to avoid increasing the consumption of electricity, because it was more expensive. And once you install the trunk line, it won't cost you anything as OPEX. So it depends on what you want to do. You do the economics and you make the decision, and I hope it's the right decision. Okay, there are a lot of things that we can talk about this, lots, but depends on the case, and whatever whatever case you can have, we can talk in the channel and help you out. All right, my friends, thank you very much. I'll see you next video.